निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students, in this session we will be dealing with the solution of exercise 12.2 from chapter 12 Heron's formula from your NCERT textbook class 9 mathematics. Let us move on with the question. Question number 1. A path in the shape of a quadrilateral ABCD, that means the path is in the shape of a quadrilateral, has angle C equals to 90 degree, angle side AB is equals to 9 meter, BC is equals to 12 meter, CD is equals to 5 meter and AD is equals to 8 meters. How much area does it occupy? That means what is the area occupied by the quadrilateral with these lengths and an angle C is equals to 90 degrees. So first of all, let us draw a quadrilateral and name the sides. So this is my quadrilateral. A, B, C, angle C is 90 degree and D. And we are given with AB equals to 9 meters, so this is 9 meter. BC equals to 12 meters, so this is 12 meter. CD is equals to 5 meter, then this is 5 meter, and AD equals to 8 meters. These are the lengths that are given to us. AB equals to 9 meter, BC equals to 12 meter, CD is equals to 5 meter, and AD is equals to 8 meters with angle C is equals to 90 degree. Now this is a quadrilateral and the area can be found out as we are dealing with, this is the part of application of Heron's formula. So we will have to apply Heron's formula. But in order to apply Heron's formula, we need triangles. Heron's formula is applicable for triangles whose three sides are known. Here there is no such triangle. That means we will have to do some construction in order to form triangles. Now what construction can be done? In order to divide this quadrilateral into triangles, we will have to construct the diagonal. Either of the diagonal can be constructed. But which one is appropriate is to be kept in mind. Suppose we join AC. Suppose we have joined AC. Now this has been divided into two triangles. For this triangle, these are the two sides. Where is the third side? It is unknown. Is it possible to find out the third side? There is no such criteria that we know to find the side AC. That means whatever we have drawn, the diagonal that we have taken is wrong. Let us try out with BD. Let us remove this diagonal and let us join BD. Now this diagonal BD also divides the quadrilateral into two triangles. Triangle BCD and triangle ABD. Again, suppose we consider this triangle. We have one side, we have other side. Oh, it's a right angle. Area can be found by half into base into height. So we don't need the third side. But when we move to the second triangle ABD, here two sides are given. The third side is BD, that is unknown. So we will not be able to find the area of the triangle if the third side is not known. Is there any way to find the side BD? Yes. Here in this case, we will be able to find the side BD from triangle BCD, which is a right angled triangle. Two sides are given. Third side can be found out by Pythagoras theorem. So it is possible. So our construction is now appropriate. So let us now move on with our solution. So we have joined BD. And as soon as we join BD, let us find the value of BD by Pythagoras theorem. So in triangle BCD, by Pythagoras theorem we can say BC square plus CD square is BD square. BC was 12 meters, so 12 square. CD was 5 meters, so 5 square is equals to BD square. So BD square is equals to 144 plus 25. BD square is 169, implies BD is root under 169, and that is equals to 13 meters. This I have told you that when the square root is shifted to right hand side, it changes to root. Now we have got the value, the side BD. That side BD is obtained. Now we will be able to find the area of triangle ABD by Heron's formula. But what about the area of BCD? Area of BCD can also be found out by Heron's formula, because we are having the three sides, 12 meter, 5 meter, the third side 13 meter. But since it is a right angle triangle, in order to minimize our calculations, we can move the simple formula for area of a triangle, for triangle BCD, that is half into base into height. So let us find the area of triangle BCD. So area of triangle BCD is half into base into height, and here the base can be taken as 12 and height as 5, and if you simplify it, it becomes 30 meter square. So we have now got the area of triangle BCD. Now we will be looking for area of triangle ABD. On getting area of triangle ABD, we will be adding both the areas of the triangles to get the total area of the quadrilateral. So let us now move on to triangle ABD to find the area by Heron's formula. So in triangle ABD, the three sides are given, so that AB is equals to 9 meter, that is given to us as A, say that we require for our Heron's formula. Then we have BD is equals to 13 meter, that we have calculated, say B, and the third side is AD is equals to 8 meters is equals to C side. So in order to apply the Heron's formula, we first of all need the semi-perimeter of a triangle. So let's find out semi-perimeter. S is equals to A plus B plus C by 2, and substituting the values of A, B and C, we have 9 plus 13 plus 8 by 2, and this is 30 by 2, this is 15. Now we have obtained the semi-perimeter. Let us move on with the Heron's formula for finding the area now. So area of triangle ABD, what we are looking for is given by S into S minus A, S minus B, S minus completely under root. Now we have S, we have just calculated. We have A, B, C that we have just taken as A, B, B, D and AD. And let us substitute and get the area of triangle ABD. This is 15 into 15 minus 9, 15 minus 13 and 15 minus 8, whole completely under root. Moving on, 15 into 6 into 2 into 7, completely under root. Let us find the factors of each and then pair it, and then let us take out the square root as we used to do in class 8. So 15 can be written as 5 into 3, 6 can be written as 3 into 2, and 2 as it is, and 7 as it is. Now let us make the pair. This is the pair and this is the pair. So 3 is out, 2 is out, it becomes 3 into 2 is 6, and root under 35. The approximate value of root under 35 by long division method, you can take this one as 6 into 5.91. If you want, this is up to 2 decimal places. If you move on, you may get up to 3 decimal places. If you want single decimal place also, it is okay. So if you multiply 6, 54, 5, 35.46 meters. Now we have obtained the area of triangle ABD, we have obtained the area of triangle BCD, and finally let us move on to find the area of the quadrilateral ABCD that was asked in the question, that is the area of the arc in the shape of the quadrilateral. So area of the arc ABCD, and that is equals to area of triangle BCD plus area of triangle ABD. And area of triangle BCD we have calculated as 30 meters square, and ABD just we have calculated, that is 35.46 meters square, and adding finally we get 65.46 meters square of area. That is the area of that part that is in the shape of the quadrilateral with the dimensions that are given to us. We have calculated the total area to be 65.46 meter square. What we have done, we have divided the quadrilateral into two triangles and we found out the area of the two triangles individually, then added them and together we obtained the area of the quadrilateral. Question number 3. Question number 2 is similar to question number 1. It is almost the same, that has been kept for you for practice. You can go through the questions and try to solve it by yourself. We will be moving on to question number 3, where there is a character named Radha. She builds a paper aeroplane with the dimensions that are mentioned in the question. These are the dimensions. This is 5 centimeter. If this is 5 centimeter, then this is also 5 centimeter. If this is 1 centimeter, then this is also 1 centimeter. 6 centimeter means 6 centimeter. 1.5 centimeter means this is also 1.5 centimeter. The total length of this one is 6.5, 1 centimeter, then 1 centimeter. Dimensions she has taken by herself, balancing the symmetry of the aeroplane, and she had made this aeroplane with colorful papers. Then what area of papers that she has used in the aeroplane is to be found out. That means we need to find out what is the area of the aeroplane. Now here if we observe the aeroplane very minutely, the total aeroplane has been divided into 5 parts. What are the 5 parts? Let's see. This is part 1. Say this is part 2. This is part 3. This is part 4. And this is part 5. These are the 5 parts into which the total aeroplane design has been divided. We need to find the area of each part, and then adding up all the parts, we will get the total area of the aeroplane. All the parts, the part 1 is in the shape of a triangle. We need to find the area of part 1. How can we find the area of part 1? If you see, we are given with 3 sides. Only Heron's formula can be applied to get the area. Then part 2 is in the shape of a rectangle. We can find the area of the rectangle by the basic formula. Length into breadth. Then part 3 and part 4, these are two right-angled triangles with equal dimensions. So whatever will be the area of part 3 will be the area of part 4 also, and that can be found out by half into base into height. Very simple. And the part 5, that is in the shape of a trapezium, and we know that the area of a trapezium is half into sum of the parallel sides into distance between them. So individually we will have to move for each part, and finally we will have to add up. So let us start. Let us move on individually for each part. Say we are moving for part 1. So this is our part 1. With the dimensions that is given to us for application of Heron's formula, let us consider A is equals to 5 centimeter, B is also equals to 5 centimeter, and C is equals to 1 centimeter. The 3 sides of the triangles. The first thing that we need to find is semi-perimeter, that is given by A plus B plus C by 2. So this is equals to 5 plus 5 plus 1 by 2, and this is actually 11 by 2 centimeters. So we have got S. Now let us find the area of the triangle applying Heron's formula for area. So this is area. You can say part 1 is given by S into S minus A, S minus B, and S minus C. Completely, and then root where we will be substituting the values of S, A, B, and C, and we will be getting the area. So S is 11 by 2, this is 11 by 2 minus 5, again 11 by 2 minus 5, and 11 by 2 minus 1. Completely, and then solving each bracket by taking LCM. So this can be written as 11 by 2 This is 11 minus 10 by 2. This is 11 minus 10 by 2. And this is 11 minus 2 by 2. So we have taken the LCM for each bracket and we have simplified it. So moving on further, this is 11 by 2. Now this becomes 1 by 2. This becomes 1 by 2. And this is 9 by 2 and taking the square. And let's consider the square root for numerator as well as for the denominator part. So 11 is not in pair, so no root is possible. 9 can be written as 3. Here they are pairs, so this is 2, again 2 for this pair, and root under 11 remains as it is. So finally we have got 3 root under 11 whole divided by 4 centimeter square as the area of the triangle, that is we are given the name part 1. So area of part 1 is 3 root 11 by 4 centimeter square. Let us move on with part 2, part 3 and 4 and so on. So area of part 2. So area of part 2, and that is in the shape of a rectangle. The area can be found out by length into breadth. So this can be written as length into breadth. And what is length? 6.5 centimeter into breadth is 1 centimeter, and finally we get the area of part 2 as 6.5 centimeter square. We have done the area of the part 2 also. Area of part 3 is equals to area of part 4, and they are right angle triangles, so half into base into height. So let us find that is area of part 3, and that is equals to area of part 4, and that is half into base into height, and this is half. We can take base to be 1.5 and height to be 6, so this is 4.5 centimeters square each. We cancel fix. We have got the area of part 1, we have got the area of part 2, we have got the area of part 3 and 4 also. Now finally we will be moving with the area of part 5, which is in the shape of a trapezium. So we will be moving with part 5. Let us consider the shape of part 5 once again for easy understanding. This is 1 centimeter, this is 1 centimeter, this is 1 centimeter, and the whole is 2 centimeter. Let us draw two perpendiculars to the longer parallel side. This is perpendicular and this is also perpendicular. These are perpendiculars. Now as soon as we draw perpendicular, if this is 1 centimeter, this also becomes 1 centimeter. And since the non-parallel sides are equal, that means the remaining 1 centimeter is also divided into equal parts, that is 0.5 centimeter, and here also 0.5 centimeter. This is only possible when the non-parallel sides are equal. If the non-parallel sides are not equal, the method of solving would be something different. So here, let us take the advantage that the non-parallel sides are 1 centimeter. Now see. In order to find the area of the trapezium, our formula is half into sum of the parallel sides into distance between them. The parallel sides are given to us as 1 centimeter and 2 centimeter, and the distance between them is unknown. This is called the perpendicular distance between the two parallel lines. That is unknown. Let us name it as h. And how can that perpendicular distance be calculated between the two parallel lines? That is by Pythagoras theorem. If you observe, this one is a right angle triangle where hypotenuse is given, base is unknown, and height is to be calculated. So let us move on by Pythagoras theorem, and we say 0.5 whole square plus 1 square is h square. That is by Pythagoras theorem. So this is 0.25 plus 1 is equal to h square. Is it? No. This is wrong. You have to look out for how to use the Pythagoras theorem. That should always be base square plus height square is hypotenuse square. Keep in mind, we will have to write this way. Base square plus height square is hypotenuse square. So keep in mind, many times students do the mistake that I have shown you. You will have to be very careful whenever you use Pythagoras theorem. So h square 0.25 plus h square is 1. So h square is 1 minus 0.25, that is 0.75. Let us change it in the form of again a fraction that would be easy for us. So h is equals to, h square is equals to 75 by 100, that is 3 by 4, and when you find h, that will be root 3 by 2 centimeters. Root 3 by 2 centimeters. Now we have got the perpendicular distance between the parallel lines. Now let us move on for finding the area of the trapezium. So area of trapezium, or you can say area of part 5. That would be much easy for us to do. This is half into sum of parallel sides. That is 2 parallel sides into distance between them. And that can be calculated as half into the parallel sides are 1 centimeter plus 2 centimeter, and the distance between them is root 3 by 2, that is h we have calculated, that is root 3 by 2. Let us calculate 1 by 2 into 3 into root 3 by 2, and this is exactly 3 root 3 by 4 centimeter square. So this is the area of part 5. Now we have finally got the areas of all the 5 shapes that makes the aeroplane, and now we need to find the area of the aeroplane by adding all the areas, area of part 1, area of part 2, area of part 3, part 4 and part 5. So let us continue. So area of the plane, that is aeroplane you can say, or area of colorful papers required for making the plane by Radha, anything you can maintain, that is area of part 1 plus part 2 plus part 3 plus part 4 and plus part 5. All the parts, all the areas. That will be equals to part 1. We have obtained the area of part 1 as 3 root 11 by 4. So this is 3 root under 11 by 4 plus area of part 2 is 6.5 plus part 3 is 4.5, as well as part 4 is also 4.5. This is part 3 plus part 4, and area of part 5 we have just got as 3 root 3 by 4. This is 3 root 3 by 4 and whole in terms of centimeter square. Let us simplify as much as possible. 6.5 plus 4.5, 11, and plus 4.5, 15.5. Plus if you take 3 by 4 common here, you get root under 11 plus root under 3, the whole as a centimeter square. You can simplify it more if you substitute the values of root under 11 and root under 3, and finally you can get the answer in decimal form. So this is how we will be calculating the area of the plane made by Radha out of the colorful papers. Next question. Question number 4. This is question number 4. A triangle and a parallelogram have the same base and the same area. So we are given with a triangle, that is draw the triangle. We are given with the triangle, and we are also given with the parallelogram. These both have same base and same area. That means area of the triangle is equals to area of the parallelogram, and they have same base. That means the measurement of the base of the triangle and the base of the parallelogram is same. Let us move on to the further. Which side is same? If the sides of the triangle are 26 cm, 28 cm and 30 cm. Suppose the side is 26 cm, this is 28 cm and this is 30 cm. These are the 3 sides of the triangle that is given to us. And the parallelogram stands with the base 28 cm. The parallelogram has the base 28 centimeters. We need to find the height of the parallelogram. That means we need to find the height of the parallelogram. Now if you observe both the figures have same base 28 centimeters and 28 centimeters. Moreover, it is said that both the figures, the triangle and the parallelogram, have same areas, and we need to find the height of the parallelogram. So what are actually we'll be doing in the sum? We are given with the dimensions of the triangle. That means we can find the area of the triangle. How? By Heron's formula. using the three sides we can find the area of the triangle, and that area of the triangle is equal to the area of the parallelogram. And we know the area of the parallelogram is base into height. Area we know, base we know, the only thing that is unknown is height. So we can find the height by comparing the area of the triangle that we'll get with the area of the parallelogram. So let us first of all move to find the area of the triangle by Heron's formula. Let us name it. Let the triangle name be ABC and the parallelogram name be PQRS. And we need to find the area of the triangle. So let us move on with the solution. This for triangle ABC. For this triangle we are given with side AB is equals to 26 centimeter. Let us consider it as A for applying our Heron's formula. BC is equals to 28 centimeters. Let us name it as B, say, and AC is equals to 30 centimeter is equals to C, say. So we are given with the three sides, namely A, B, and C. First of all, we need to find the semi-perimeter that is given by S is equals to A plus B plus C by 2. So let us substitute the values of A, B, and C. 26 plus 28 plus 30 whole divided by 2. So this is 26 plus 28, 54 plus 30, 84. 84 divided by 2 is 42 centimeters. That means we have got the semi-perimeter as 42 centimeters. Now when we apply Heron's formula for area of the triangle, so this area of triangle ABC, that is given by S into S minus A, S minus B, and S minus C completely under root. Now we have all the four values. S also we have 42 centimeters, and we also have A, B, C. All the four values are available. Just we'll be substituting, simplifying and solving, and we'll get the area of the triangle. So S is 42, 42 minus 26, 42 minus 28, and 42 minus 30. There is a black what is given in the brackets. 42 minus 16 is 16, 42 minus 20 is 14, and this is 12. That is factorized in such a way that we will be able to make pairs to find the square root. So this can be written as 6 into 7, that is 42. 16 can be written as 4 into 4. 14 can be written as 2 into 7. And 12 can be written as 2 into 6. Now let us make pairs. We have a pair of 6, so this is 6. We have a pair of 7, so this is 7. We have a pair of 4, so this is 4. And we have a pair of 2, so this is 2. And if you multiply it, you get 6 into 7, 42. And 42 2s are 84. And 84 into 4 is 336 centimeter square. So finally, we have got the area of triangle ABC. We are given with area of triangle and parallelogram are equal. So area of parallelogram will also be 336 centimeters square. So area of parallelogram, this is the symbol that we are using for parallelogram, PQRS, and that is equal to area of triangle ABC. Area of parallelogram is given by the formula base into height, and this is equals to 336 centimeter square. Here for parallelogram we were given with 28 centimeters, so this is my base, and height we have considered as h, so this is equals to 336 centimeters square. Solving we will get h as 336 by 28, so h is equals to 12 centimeters. So finally we have got the height of the parallelogram. The height of the parallelogram that is given to us is 12 centimeter with the condition that the area of the triangle and parallelogram are equal and have same base.